We're asked to solve this for t, so we got to get 0 on one side. I'm going to put the thing in order. So we have gt squared over 2 plus v naught t minus s equals 0. That allows us to write down the ABC for the quadratic formula. A is now g over 2 because we're solving for t because it asks us to. And b, the coefficient of t, is now v naught, and c is minus s. Notice this formula you may not understand very well. It describes our real world to a certain extent. It comes from the land of physics, and we're doing math to it, but that doesn't necessarily mean we understand where the formula is coming from. We'll do a little bit of that in the next few problems. So we have, in this case, t, we're solving for the letter t, equals the opposite of what b is. b is v naught, so it's the opposite of v naught, plus or minus the square root of b squared, which is v naught squared, minus 4 times a times c, which is g over 2 times a minus s, all over 2 times a. Now that's pretty much the answer, except we need to do a little bit of work. The 2's here cancel, and we have g, and we have minus v naught plus or minus the square root of v naught squared, and a negative times a negative is a positive, and we have a 4 over 2 canceling 2 at 2, gs. Now t stands for time, and usually we don't think of time as being negative, so this plus or minus sign, if it was a minus sign, the numerator would be negative because we'd have a negative take away some more. And if the numerator is negative and g is positive, then we're going to have a problem. So it would seem as if we need to have a plus sign because the negative sign doesn't lead anywhere real. So that is our formula for t. It's a little bit empty since we haven't used it for anything, but we'll use it. We'll use this kind of thing in the next few examples. In problem 25, we're given a word problem and we're given a formula to use. And in this formula, t stands for time. And that time is measured in seconds. And s stands for distance, and that distance is measured in meters. And so the guy has to fall 40 meters before the cord starts to stretch, so we're given that the distance is 40 meters and we're asked to find the time. So we have 4.9 t squared equals the distance traveled, which is 40 meters. And so we need to solve this for t, and we can do that pretty easily because the square is already completed. We have t squared equals 40 over 4.9. So we're going to take the square root of both sides and put a plus or minus in, and we have t equals plus or minus the square root of 40 over 4.9. But time being negative is somewhat problematic, so we're going to have the square root of 40 over 4.9, and that t will be in seconds. Now I did that on a calculator, and I got that it's, roughly speaking, something like that. So the question is, how do we round it off? I'm going to round it off to the nearest tenths. This 5 kicks the 8 up to a 9, so I have about 2.9 seconds before that bungee cord starts to stretch, because that's how long it takes him to fall 40 meters. Problem 27, we're given a formula to use to calculate LeBron James's hang time for his 44-inch leap. And so we have two variables. V equals the vertical leap distance in inches, and T equals hang time, which is the amount of time his body's in the air, in seconds. And so we're given that it's 44 inches, so we have 44 equals 48 times t squared. Again, we've got the squared term by itself very easily, so we have t squared equals 44 over 48. We could reduce the 44 over 48, but I'm going to be using a calculator anyway here shortly. Again, time can't really be negative, so let's get rid of the minus sign and plus or minus. And so since I'm going to do the square root of 44 over 48 anyway, it doesn't make much sense to me to reduce it. I'm just going to grab a calculator, and I get something like 0.957427108. I say that just so you can make sure you're pressing the right buttons in the right way. I'm going to round this off to something, maybe hundredths of a second. So I'll use the 7 to kick this up and have 0.96 seconds. So just a little bit less than a second. You could choose to round this off to 3 or 4 decimal places, or I suppose even 1 decimal place, but that loses quite a bit of accuracy. So I think this is acceptable. So we're given this formula to work with, and in working with a formula like this in the real world, physics, biology, chemistry, whatever, it's a good idea to know what your variables mean, but it's also a good idea to know what kind of units you're using. That can help you a great deal. So armed with this knowledge, let's go ahead and find or solve for the initial velocity v0. We know that time t is 3 seconds. And we know that the distance s is 51.6 meters. So we put in the 51.6. We put in t equals 3. For t squared, we put 3 squared. And so I'm going to call the 3 squared 9. So we have 9 times 4.9 plus v0 times 3 equals 51.6. Subtracting this from both sides, we could have v0 times 3 equals 51.6 minus 9 times 4.9. Dividing both sides by 3, this whole right-hand side by 3. We now have v0, and we have a calculation. I'm going to do that on the calculator. And when I did that calculation on the calculator carefully, I got exactly 2.5. And we know that v0 is the initial speed in meters per second.